Hi there. In this video, we're going to be solving what are known as two-step equations. And as the name implies, these equations are going to take 2 steps to solve. So what we're going to do is start with a fairly basic example of 2x plus 5 is equal to 15. Now, a lot of you can look at this and already know that the answer is equal to 5 because 2 times 5 is 10 and 10 plus 5 is 15. So I don't want you to focus on the answer so much this time, so I want you to focus on the process. What we're going to do is we're going to read this problem by starting with the variable x. All right, now what you have to do is keep in mind that as you read this, you have to follow orders of operation. Parentheses, exponents, multiplication, division, addition, and subtraction in that order. So we're going to start with x. My variable is x. And following orders of operation, I would multiply by 2, because it's implied 2x is 2 times x. So now I've got x, below it I'll write times 2, and then after that I would add 5. And that's following orders of operation. I would go x times 2 plus 5. But what we're doing here is we're actually working backwards in the problem to try and figure out what x is. So we're going to go in reverse order, and we're going to do opposite operations. So the opposite of adding 5 is subtracting 5. The opposite of multiplying by 2 is dividing by 2. And if we do everything right, that's going to get us back to x. So we're going to focus on this column right here, because it's telling me what to do and in what order, because we're going up the column just like the arrow indicates. It would tell me that I'm going to subtract 5 from both sides of the equation over here first. So I'm going to subtract 5. Now, on the left-hand side of the equal sign, we still have the 2x, or 2 times x, plus 5 minus 5. Those cancel out. That's 0. Bring down the equal sign. Always remember to bring down the equal sign. And 15 minus 5 is 10. So we've done the minus 5. Now we move on to the dividing both sides by 2. So I'll show dividing by 2, dividing by 2. So I'm doing this step, dividing by 2. And if you look, we have a 2 in the numerator and a 2 in the denominator. And that all cancels to become 1, leaving me just x. So I'll bring down the x, bring down the equal sign, and I have 10 divided by 2 is 5. Just like I predicted it would be. So there's my answer. But before I call it done, I have to remember to check it. So I'm going to take 5 and plug it back into the original equation. I've got 2 times, take out the x and put in 5, plus 5. So I've got 2 times 5 plus 5, which is equal to 10 plus 5, when 10 plus 5 is 15. So there's my check. I know I'm right because I've got a 15 here, and that's what it equaled up here. Now let's look at a different problem, and this problem is going to be different in a couple ways. Here's your next example, and it is 10 equals m divided by 2 plus 2. Don't let the m fool you. It doesn't matter what variable we use. This time I'm going to use an m. Now what's different here is that before the x, the variable, was on the left-hand side of the equal sign, whereas down here my variable m is on the right-hand side of the equal sign. Up here I was going 2 times x, so it was a multiplication problem, but down here it's m over 2, or m divided by 2. It's a division problem. But what's important to note is the process doesn't change. I'm going to start the problem by reading m and then going through the orders of operation. So here's m. I would divide by 2 first, and then after dividing by 2, I would add 2. So let's create our roadmap. We're going to do it in reverse order and opposite operations. The opposite of adding 2 is subtracting 2. The opposite of dividing by 2 is multiplying by 2. And if everything's done right, that gets me back to m. So here's what I do and in what order. It says to subtract 2 from both sides. So I'm going to show minus 2, minus 2. 10 minus 2 is 8. Equals, I have the m over 2, or m divided by 2. But positive 2 and negative 2, those cancel out. So what I've done is I've done this step here. Now I'll move on to the next one, which is multiplying both sides by 2. So I've got times 2 here and times 2 over here. Well, 2 times 8 is 16, equals, bring down the equal sign. Now over on this side, if you look at this, think of this 2 as 2 over 1, because 2 over 1 is the same as 2. You can see I've got a 2 in the denominator and a 2 in the numerator, and those can cancel out, leaving me with m over 1, or just m. There's my answer. But I'm going to check it by plugging it back in. Take out the m and put in 16, then over 2 plus 2. That's equal to 8 plus 2, which is equal to 10. And there's my check. 10 here, 10 there. So I know that m is equal to 16. You could also write the answer as m equals 16. Now I've got a different problem I want to show you. At first, it may not look like a two-step equation, but I think you'll see it after we make one small modification. Negative x plus 15 is equal to 12. And at first glance, this may not look like a two-step equation, but what I'm going to do is focus on this negative x. Now, negative x is the same as saying take negative 1 and multiply it by x. This is the same as that. Then I have the plus 15 equals 12. Now, do you see a two-step equation? We start with x, we multiply it by negative 1, and then we add 15. So we're going to do reverse and opposite operations. Adding 15, the opposite of that is subtracting 15. Multiplying by negative 1 is the same as dividing by negative 1. So here's my roadmap, and it's going to get me back to x. So we'll start with subtracting 15 on both sides. Minus 15 here. I have negative 1 times x, but the 15 minus 15, that cancels. Bring down the equal sign, and 12 minus 15 is negative 3. So I've done the first step. Now let's move on to the next one, which says to divide both sides by negative 1. Dividing by negative 1 on both sides. Now look right here. Negative 1 over negative 1 cancels out. I know they're both negatives, but if you remember, a negative divided by a negative is a positive, so these become positive 1. 1 times x is just x, equals negative 3 divided by negative 1. A negative divided by negative is a positive. 3 divided by 1 is 3. There's my answer. But I'm going to check it. I take the 3 and I put it in. Now I've got negative x, but there's the negative x, but x is equal to 3, so I'll put in 3 plus 15, which is equal to 12. There's my check. Okay, here's another problem I wanted to show you. I'm calling it part 2 because this type of problem is just a little bit more difficult. It can be a little intimidating. So let's take a look at this example. It is y plus 1 divided by 3 equals 2. And you can see just the way this problem is set up, it looks a little harder because you've got y plus 1 in the numerator of a fraction and 3 in the denominator of a fraction. But if you're comfortable with the process you saw in the previous videos, even this problem isn't that difficult because it's the same process. We're going to start with the variable y. That's what we're solving for. Now keep in mind, we have y plus 1 in the numerator. In effect, this is grouped by a set of parentheses you just don't see. You have to add 1 first. Once you've added 1, you're dividing that entire quantity by 3. So divided by 3. Now, create our roadmap. We're going to do it in reverse order, and we're going to do opposite operations. The opposite of dividing by 3 is multiplying by 3, and the opposite of adding 1 is subtracting 1. And that'll get us back to y. So we're focused on this area right here, this column. It's telling me to multiply both sides by 3 first. So I'm going to show times 3 and times 3. Now what happens over on the left-hand side of the equal sign is you've got this 3, but I want you to think of it as 3 over 1. 3 over 1 is equal to 3. Now you can see a 3 in the numerator and a 3 in the denominator. Well, those cancel each other out, and we're left with y plus 1 over 1. But I don't have to put the over 1 because anything over 1 is itself. Equals 6. So you see how by multiplying both sides by 3, we in effect cancel the 3 in the denominator. So we've done that step. Now it's telling me to subtract 1 from both sides. Y plus 1 minus 1, well the 1 and the minus 1 cancel, we're left with just y equals 5. And of course we're going to check it. We're going to take the 5, plug it back into the original problem. So it was y plus 1, but we know y is equal to 5. So I've got 5 plus 1 divided by 3. Well, that's equal to 6 over 3, and 6 over 3, or 6 divided by 3, is equal to 2. So there's my check. So this problem looked intimidating, but if you follow the process, it gets you right to the answer where you want to be. Y is equal to 5.